Upgrade ports are a very useful thing when it comes to optical multiplexers. After all, it is impossible to cascade multiplexers to increase the number of services being multiplexed. But did you know that there is more than just one type of upgrade port, and these different types of upgrade ports are actually essential to get the most of your WDM setup and your investment? If you want to find out more, stick around and we'll check it out. When we're talking about optical multiplexers with a smaller number of services being multiplexed, so in other words maybe a 4 or 8 service multiplexer, generally speaking the technology behind it then is based on a thin film filter cascade. In other words, what that means is that each individual channel actually has its own filter, and that these filters are then connected to each other based on the reflection of the previous filter. And that is also where the standard upgrade port, so in other words the most commonly known upgrade port, actually comes from, because that upgrade port basically is only the reflection of the last filter in that filter cascade. And that is great because it makes it a very cost-effective upgrade port. But the downside is that the optical performance of that upgrade port really isn't very good because it is at the end of that filter cascade. Now, during the many years that we have working on customer projects with customers all over the world on their passive optical networks, we actually always came across a situation that the optical performance of that standard upgrade port actually isn't enough for many situations. And that's why we actually designed very specific and new upgrade ports which enable more topologies for passive optical networks and also make them more efficient. Let me explain. Now, the first special upgrade port that I want to talk to you about is based on the requirements that a daisy chain setup is required. In other words, we've got a site A with a big multiplexer, multiplexing many services, and then we go to the next smaller site, which uses a smaller multiplexer, extracting only a subset of these channels. And that then goes on to the next site, once again extracting a subset, and so on and so forth. Now, these individual sites are connected to each other by using the upgrade port, but the distance between these individual sites actually can be many kilometers. So in other words, you need to have a really good optical performance of the upgrade port, which the standard upgrade port generally doesn't offer. And what we then did is we actually designed a special upgrade port by adding another filter. And since this upgrade port is very specific for a daisy chain application, we actually called it the daisy chain upgrade port. Now, the next upgrade port that I want to talk to you about is the so-called enhanced upgrade port. And this enhanced upgrade port is based on the requirements that customers said to us they would like to be able to use that upgrade port, that idle upgrade port, as an additional service until that day when they actually want to use it as an upgrade port. In other words, want to add another multiplexer. Now, the point is that with a standard upgrade port, that isn't possible because the optical performance, or more precisely the isolation of that upgrade port, nowhere near is good enough to be able to do that. But with the enhanced upgrade port, we changed that because we added an additional filter to the cascade, making the isolation of the upgrade port good enough so that you can actually use it as an additional service, making, for example, a 4-service multiplexer actually into a 5-service multiplexer until that day when you want to use the upgrade port to add an additional multiplexer. Last but not least, let's have a look at a CWDM and DWDM hybrid setup. In order to do that, let's first have a look at the grid of CWDM and DWDM in relation. So in other words, for CWDM, we've got the blue band, which are the wavelengths going from 1270 to 1430, and we have the red band going from 1450 to 1610. Now, the point is that the DWDM grid sits right bang here in the middle of that red band. And because that's the case, what you normally do is you use a CWDM multiplexer of the blue band, and then you connect the DWDM modules to the upgrade port. Now, the point is that you actually, by doing that, you are losing those 5 additional very valid channels in your setup. And that is something that we solved with the express port. Because what the express port is, it's for a specific red band CWDM module which has exactly those 5 additional channels that are left over to the left and right of that DWDM band, and the express port actually only cuts out exactly that DWDM band. So in other words, you can have the blue CWDM module that is then connected via the upgrade port to that very specialized red CWDM module with those additional 5 channels, and then the express port connects to the DWDM modules. Now with these 3 very specialized upgrade ports, we are able to cover far more applications and requirements than with the standard upgrade port. So that's basically it. I hope you learned something today and that you enjoyed this video. If so, please leave a comment. Also, maybe let us know if you're working on a passive optical network design and maybe you're looking for a very specific setup that you can't do with a standard upgrade port. Thanks for watching and see you soon.